This is the fourth in a series of modules about productive tutoring techniques. You, the viewer, will have an opportunity to see actual tutors handling real tutoring situations. These scenes will benefit you the most if you take time to think about and discuss what you see. Throughout this module, this screen will appear as a prompt for reflection and discussion. All tutoring sessions should build upon the correct ideas of the student. A good tutor will expend considerable effort and energy in trying to understand the current thinking of the student. As noted in Module 3, students master course material by building on their own ideas, not those of the tutor. Therefore, encouraging students to express their ideas is very important. All ideas of the student, right or wrong, should be acknowledged by the tutor. Good tutors correct the student's mistakes as needed, but they tend to emphasize the correct ideas. If students reveal a correct understanding, there is usually little need for the tutor to further elaborate on the concept.
Energy is given off.
Right.
So it's exo. But when
So
they're separate, like when they're broken apart like this, then they're endo. Because they need energy.
Okay, now when you have these separate and you're going to this, is it endo or exo?
It's exo.
Right.
But like if this was backwards, then it would be endo.
Yeah.
Okay. Okay.
As in this case.
Yeah.
Will be entropy. They're all going to have.
These all have to do with the transfer of energy to a different system or within the system. This is just the energy of that system.
Yeah, exactly. So that's probably right.
By trying to see if a face was different in a particular area. I think I should put would one be able to recognize it at the beginning of the sentence so it would be a little bit clearer.
Okay. So how would that read?
Okay. By trying to see if one would be able to recognize it if a face was different in a particular area. I think that sounds much better.
I think you're right.
As we learned in Module 2, a big benefit of positive reinforcement is that students become more willing to share their ideas. Let's see how this works.
Reactants to products. Example, here you have H2 and Cl2 and you're forming this. So can we look at this like this?
Yeah.
I mean, he didn't do that, but so like here you have two separate molecules and they're bonding or they're turning into one, so they're bonding. So they're going to be exo.
Okay, well, let's think of this as a two-step process.
I would plug in maybe 2 or 3 points, just like you did here. I think that was a good idea to plug in points, and I know it takes some time, but I think that was really a good thing to do. Maybe not like a bunch of points.
Maybe -5, 0, and 5.
Yeah.
In a way, the technique of using the student's ideas is just a very specific form of positive reinforcement. Notice here how Katie notes the specific things that were correct in her student's reasoning.
Okay. All right, that's exactly right. Your formation constant equals your product over your reactants. This is good. You remembered to raise it to the fourth, so that's exactly right.
Active listening responses may be used by tutors to determine if they understand the student's ideas. If the student's message has been paraphrased correctly, the student will usually respond, sending a verifying message that means, yes, that was what I meant.
But why does he have work and heat here and the different types?
So your question is, what's the difference between work and heat?
Redirection is when a question is turned back to the student, usually in a simplified form.
Okay, and then this is in, what is this, K? Is this, I know that J is joules. I guess K is just...
What's K usually? Like kg, what's that?
kilograms.
Yeah, so it's...
this is just kilos.
Here, Katie helps her student understand that he possesses all the knowledge needed to answer his question.
All these type things with KF?
Yeah, well see, look at all the formation constants. they're all a lot greater than 1. So what does that mean?
That's it's real soluble.
Okay, and in terms of the reaction going to completion or not, does the reaction go to completion?
It's going to completion.
Okay, good. How do you know?
Because it's got a big KF.
Okay.
Now, watch as Beth uses redirection to get the student to reveal his thinking on the question. This allows her to diagnose his problem and gives her an idea of what action to take.
Around 25 cents were used for the study in each experiment. Can you say that? I mean, is it grammatically sound?
Well, what's your subject? What's your verb? Does it stand alone? And you tell me.
Okay, well, I got a subject, verb, subject. This couple verbs, and then the completion here were used was the verb. 25 students was the subject for the study in each experiment, period. So I think, yeah, it's down on its own.
Okay.
Sometimes in tutoring sessions, it happens that both parties will speak at once. When this occurs, the student's thoughts and words should be given priority by the tutor.
All right, if it's asking for the change in the pH of water.
From the pH of just regular water.
So
It's just neutral.
exactly. So then, well, you would just find the pH of. How would you?
You just do the dilution equation, right?
Right.
With the hydrochloric acid in the water.
And then you'll get a new molar concentration.
And to find the Ka, you just do the H3O concentration. I mean,
You don't need.
Ka. Yeah, you don't need Ka.
Do you? How do you find the pH of it?
Oh, yeah, negative log concentration.
Yeah. So that's all. And then you.
So you find this the concentration of the H3O or the H plus.
Right. Exactly.
This is the acid, so you know it's going to be accepting electrons, right? So
I think I see it.
okay, let me see.
Okay, it's accepting electrons. Can an electron be in the form of a proton? No, because when this separates, it has a proton and an electron. Or no, it doesn't have anything.
It's just a proton.
And remember, it's got to go off this way. It's got to come over here to 5. Like I would, like you know that X has got to be.
But it starts at 5.
Not exactly. The point that used to be in the middle moves over to here. But remember, your graph continues in both directions.
This is like a...
Good tutors always take the thread of the student's reasoning and follow it wherever it leads. Watch Kim as she tries to see the concept through the student's eyes.
This one, the H forms here, it comes down here, and the CO comes and bonds with that. But the difference in this, because it's peroxide.
Well, I know where you're going. You're saying peroxide should add. Well, here you're not going to have Markovnikov addition or not because of the fact that you're doing free radical chemistry and all the rules.
So it doesn't matter?
No.
Okay, so light and peroxide is pretty much the same thing? Okay.
Yep.
Let's see some more examples of tutors building on the student's idea.
I'm confused here because you haven't mentioned painting faces or houses before this.
Oh, yeah.
Do you explain about the faces and houses later on?
Yeah, I mean, in my, the other page and some here too. I mean, like, pretty much here in the second experiment, the first experiment right here, I'll kick in. In the first experiment, subject was asked if they could see a difference in between a couple faces.
Okay.
And then I mentioned in the second, subject would identify faces, blah, blah, blah. Third and fourth, same thing about houses.
Okay. So maybe this part doesn't make sense because you haven't explained it yet. So how could you change it to make it make sense?
As I will mention later on the paper, or something like that.
Yeah, that's fine.
So the more positive the number, the stronger the oxidizing agent.
Right. So if this is the stronger oxidizing agent, when we write our reaction, On the reactant side,
It's really confusing.
yeah.
So this, all right, if this is a strong oxidizing agent, then it's going to be reduced.
Right.
Okay.
So if it's being reduced, then this is fine, the way this is written. We have
Right.
SN2 plus.
Are you talking about equilibrium with the vapor pressure or the boiling point?
The boiling point.
Think about it.
Well, that's when you're.
You just explained to me that all the liquid molecules are going to go to gas.
Mm-hmm.
So is that an equilibrium?
No,
And that's what? Vapor or boiling point?
that's your boiling point.
Right.
Okay,
But what's happening at the vapor pressure?
that's when your liquid and your gas are equal.
Yeah.
Okay.
Say a little more detail.
Like that's when your liquid and your gas are in equilibrium.
Which means, I mean, yeah, you can
That
say that's
means
equilibrium,
how
but what's really
much-
happening?
All the liquid that goes to gas, then you have that much gas coming back to your liquid.
Right.
Okay. Okay.
A tutor needs good listening skills to use the technique of delayed positive reinforcement. The use of this technique yields the combined benefits of building on students' ideas and positive reinforcement. Tutors are using delayed positive reinforcement whenever they remind students of correct ideas they stated earlier in the session. This allows students to build solutions upon their own correct ideas. It also demonstrates to them that the tutor has been carefully listening to them.
So up here, when you solved for the inverse, you were right, that was the inverse, but they want that in the form of y equals instead of x equals something. Was that if you find out the domain for the original function, that is the range of the inverse function. You already told me that the domain of the original function is equal to the range of this. But you were right before when you were saying set something equal to 0, and that's what you would set equal to 0.
Let's review the ways that tutors encourage and use the students' ideas in a tutoring session. The use of appropriate levels of positive reinforcement and acknowledgement of all student ideas helps to encourage students to share more of their ideas. Active listening responses may be used by the tutor to clarify the students' ideas and to improve communication. Redirection may be used to show students that they have the ideas needed to answer their own questions. In discussions, the tutor should always yield to students because students must work with their own conceptions. The tutor may help by then building on the students' ideas with feedback and questions. Lastly, experienced tutors often use the technique of delayed positive reinforcement when they recall and emphasize a correct idea expressed by the student earlier in the session.